Good morning, good afternoon, and for those of you that are in an area that is further away, good evening. My name is Andre Makika. I am the Country Manager for One Spatial, and welcome to the One Spatial Australia GDA 2020 case studies. We will now move on to the informative part of our presentation from Jamie McKinney, Spatial Systems Officer at Bayside City Council. Jamie, thank you very much for your time this afternoon, and I will hand it over to you to introduce yourself and your presentation.
Thanks very much, Andre, and thanks to One Spatial for the opportunity to present today. So as Andre mentioned, Jamie McKinney is my name, so Spatial Systems Officer from Bayside City Council. The topic of my presentation today is our GDA 2020 transformation. So in today's presentation, I was going to cover the following topics. An overview of the project, the planning that went into it, and from that planning, the project requirements that came out. Then we chose FME to be a central part of this data transformation. So why did we do that? Also, the methodology that we followed, the tools that were required, some of the challenges that we encountered, and the learnings from this project. So this slide here is a graphic that gives us an idea of what was involved in our GDA 2020 transformation. So I've numbered the lines there just for a little bit of clarity. So starting at the top there in number 1, we were able to archive 16,000 files as we went through this particular project. Number 2 shows there that we were using new infrastructure, so we had the opportunity to have new GIS and database servers for this particular project, and so we actually moved 73 or copied 73,000 files across to a new infrastructure. These particular files in this category were in the main aspatial files, or those that non-spatial files we needed to get across, but also there were GDA94 files that we flagged as such, and we'll come back to that a little bit later on. But number 3, that line shows, I guess, the biggest aspect of this particular project was the data transformation. So 3,280 approximately data sets, which made about 10,000 files. So they were transformed from the previous datum, GDA94 in the main, to the new GDA 2020. The lines 4, 5 and 6 here show that it wasn't just a data transformation exercise. There was also software that we had to upgrade to be able to read this new data. So that included our spatial corporate viewer, Intramaps, being upgraded from version 9 to version 9.8. We also make use of MapInfo at the back end, so upgrades to version 17.0.4. And our QGIS software that we use for desktop mapping and data editing, upgraded from version 2.18 to version 3.10. So just a quick summary of the methodology, which I'll come back to in a bit more detail. But basically we used FME to compile a SQL Server table, which we've termed our data audit list. And then we used FME to read that data audit list to perform the actual transformations. So certainly FME is very well known as a data translation tool, but this was something that personally I hadn't done before, was actually have the whole process being database driven. That is to use FME to compile this data list, to record instructions for FME to actually translate the data in that data list, and then to record the final outputs as well. The work of this GDA 2020 transformation, the bulk of it was done internally by our Bayside GIS team, but we also did require external assistance. So we purchased a FME database version license from One Spatial. We also had vendor assistance from our corporate viewer vendor Intramaps, so Technology One, to help us with that 9.8 version upgrade. And we needed to also get consulting to assist with our Intramaps Roam upgrade, our mobile data capture software. The bulk of the work was done during a 10-month period from January to October 2020, and we went live in October 2020 with our GDA2020 data. There'd been also preparation carried out in 2019 as well. And just at the bottom of that slide, I've showed the coordinate reference systems that were involved in our transformation from the different reference systems under GDA94 to their equivalent in GDA2020. So there was a lot of planning that went into our GDA2020 transformation project. We started with GIS team workshops and also discussions with our IT team. And from those discussions, we developed a detailed project planning document. And I'll just show just some of the things that we covered there in that particular document. Things such as the scope of the project, the alignment to our strategic direction. Also very important about stakeholders, relationship to other projects, and risks that we'd identified as well. We also engaged our communications team so that there was organisational awareness of this project and the effect that it might have on staff and their work. So just here is an example of some of the communication that went out that was put in a language that was hopefully understandable to the organisation, and we really appreciated the assistance of the comms team there. We also organised staff information sessions once again to create that awareness of the project, and we were interested in staff coming along if they were a user to one of our corporate spatial systems, if they were editing spatial data, or if they were a project manager perhaps involved in giving out spatial data to external parties. We wanted them all to be across the project and aware of it. So from that planning stage of the project came a number of requirements. So as I mentioned, we had the opportunity to use a new IT infrastructure for the project. So we had a new file server and database server. So the brief was there to really get all of the existing files from the file server across to the new infrastructure, but transform the spatial files to GDA2020 as we did that. We took the approach that we would only put GDA2020 data on our new servers, and the exception was there if there was any GDA94 data that went across, we'd have to clearly flag it as being in that particular datum. We also wanted to archive wherever possible, so to clean up the data and reduce our transformation exercise as well. Also, we wanted to be able to keep an audit trail for any file that we had identified in our audit. So to be able to know what happened to that file in the project. Was it transformed at all? Did we archive it? What coordinate reference system was it transformed to? We wanted to keep track of all of that. And we saw that it would be beneficial to be able to do this in batches, not have to do it all in one very small transformation window, but actually do it in batches that really suited our timings. So these were some of the project requirements that came out of that planning stage. So we decided to use FME as the conversion software for this particular project. So what were some of the things that led us to that decision? Well, a number listed there. It's really shown to be a very accurate spatial translation tool. Also just supported the use of the distortion grids, which really gave the best accuracy of translation. Also, FME is very well known for being able to handle so many different file formats. And in our data audit, we had vector files, raster files, elevation files, and we were able to use FME for all of these. Just shown here in this slide some of the file extensions that we looked for, and this is from one of the FME workspaces involved in the project. But you might see there vector files like tab, dat, id in mapinfo files, but also DXF, DWG, raster files, ECW, TIFF, these ones, and also elevation files like LAS and ASC as well. Another thing that led us to using FME was we had FME skills in-house, so this enabled us to do the bulk of the work within our GIS team. Also, we had a particular need to be able to transform SQL Server spatial data, and we had confidence in FME being able to do that. And finally, we were really wanting to use this database-driven method so that everything about our transformation exercise was recorded in this database table. So there was an audit trail of what was done, and that was built into the process. So we found that that was a really important thing that FME facilitated. So the project stages that we went through, that we planned for, the project methodology is shown there. A lot of those, I guess, are fairly conventional and straightforward. I won't go into a lot of detail on all of them, but just a couple of points on some of those. The second one there says test file type conversion. So for each spatial data type that we identified in the data audit, we then tested the proposed data transformation solution using FME. In the data and software transformation, we used FME to actually perform the transformation, and I'll just show this was the workspace that we ended up using. I won't go into a lot of detail there, but you can see that there is a preparation stage for the transformation, but then there are different streams for whether the file was a shapefile, tab file, ECW, etc. and our SQL Server data here down the bottom. Then coming through into the also in the data software transformation, we were able to do things in batches, as I mentioned earlier, and we found that was beneficial because we could get the data that was ready or that was needed for our Intramaps installation, so we could target that batch of data firstly, and then that software Intramaps 9.8 could be installed on our new IT server infrastructure. Then we went live in October, and there's just a screenshot of the notification of going live to our users. So that occurred in October 2020. So the tools that were needed for us to be able to do this transformation project. So we made use of FME database version. So we needed to upgrade to that version because we wanted to transform SQL Server spatial data. As I mentioned, we made extensive use of this data audit list that this database table that we built in SQL Server. We used MapInfo linked table functionality to provide a way of editing rows in that table as required. And finally, we made use of a utility that's provided by the ICSM called GDA. So in addition to performing checks as to whether data layers were correct relative to each other, prior to conversion, we also checked our conversion software against this external tool. So we just wanted to ensure that as we went along, all of our conversions were performing correctly against a known standard. So that was an important check that we had as well. So in the next 3 slides, I'll just give an idea of how we used that data audit list. Firstly, to compile a list of the data that we had that needed to be accounted for, then to provide the instructions for transforming it and recording what actually occurred. So firstly, we use this this data audit list in the data audit stage of the project. And basically we used FME, then this particular workspace here. We got it to read file folders on our file server and bring back all of the data that was of interest, all of the file names. And down here in this screenshot at the bottom, it shows just a selection of the fields that were populated about those files. So the category, whether it's a vector or raster, the physical server details, database details, table name, including whether it had geometry, what the geometry field was. Also for file-based files, well, the file path and file name, its data format, and the coordinate reference system that it was stored in. So we got FME to populate this data audit list, this SQL Server table. So then the next stage was to compile proposed transformation details for these particular files. And in this example down the bottom, I've shown the same selection of files. The yellow is the original fields that were compiled. So then we populated some fields that would give FME the instructions of how to transform this. So including, what was to be the destination coordinate reference system. Also the method that we were going to use in accounting for this particular file. Were we going to use FME to convert it? Did we only need to copy the file over? So for instance, down the bottom there, the second last row, there's a PDF file. So this obviously not a spatial file, but it needed to get onto our new infrastructure. So we could account for it it was just going to be a file copy. Or if something was to be archived, we could say, well, no conversion needed. So these fields highlighted in the orange here were populated using MapInfo linked table to edit the underlying SQL Server data audit list. And then finally, we performed the actual transformation. So FME read the details from our data audit list and then did that actual transformation. That was the FME workspace that I showed before that we ran at this particular point of the project. So shown here is just in yellow was the original data field. So just sort of cut that down to just the database table name and the file name, but then highlighted in green the data that was recorded about the actual transformation that was done, the final physical server location, final database name or file path, the conversion method used, and also the coordinate reference system that was used. So what were some of the challenges that we encountered? Well, one was about data interoperability, so reading data that's written in one application and reading it in another. So we found that we had a difficulty in that our existing method had been to use OGR to OGR for MapInfo exports nightly from our SQL Server tables to MapInfo tab. But we found there was a problem that MapInfo actually interpreted these files that had been written as being WGS84, which resulted in a displacement when they were viewed in MapInfo. So solution that we came up with, we went live with FME doing the nightly scripting of these exports from SQL Server to MapInfo. We also found that there was a problem with QGIS reading these GDA2020 MapInfo tab files that had been written. We used QGIS with our data editing, but But the problem was that QGIS tagged these GDA2020 map info tab files as being unknown CRS. It displayed them in the right location, but they were flagged as unknown CRS, a bit confusing for users. So our solution was that we instructed users how to manually set this particular value. And there is a new QGIS version which will fix this difficulty. Another challenge we encountered was that not all organisations that we transferred data with were ready for GDA 2020. Some contractors, for instance, were using it, some still on GDA 94. So the solution there, we found that we needed to give these organisations and contractors who are requesting data, spatial data of Bayside, we needed to give them the choice on their data request forms, choosing which datum they would like to receive that data in. And to facilitate that as well, we needed to set up an FME workspace to allow us to easily convert all of our whatever data was needed from our corporate list into either GDA 94 or GDA 2020 for the contractors. Also in our process, because we were needed to account for every file as it went from the old infrastructure to the new, there's a difficulty with multi-files spatial formats. For instance, map info tab files might be just referenced by the tab file name, but actually involves these 4 other files. So we needed to manage this and flag these other files when, for instance, the tab file was converted. So some of the learnings that came from this project that we came across, just the importance of tracing all of the software and data paths thoroughly through. So with that problem I mentioned with our OGR to OGR map info exports, this was something that we assumed would be covered by our intramaps being GDA 2020 compliant. So that was an assumption that I made, so I'll put my hand up here. But actually, this tool is an open source tool, so it wasn't the vendor's responsibility to ensure that that was working as expected. So we learned that lesson of testing every component in the process, even when we assume that it'll be okay, thoroughly testing all of that. We also found that we probably went through a bit of pain as a result of being an early adopter of GDA 2020, because some of those difficulties that I've outlined have now been resolved by updates to the tools and software involved. Also, that the fact that some organisations weren't on GDA 2020 yet meant that we had to develop some interim processes. So we're very happy that we have done the transformation already, but organisations going early may encounter some more pain as a result of going earlier. We did find that there were some great resources though, including those listed from the ICSM, including a video about GDA 20 transformation and why it was necessary. We had some great help from DELP in Victoria here, and also networks within our local government sector. The Melbourne South East User Group was really great. Just some more learnings that came from the project as well. We found that the method of using new infrastructure was something that worked for us. We had clarity of what was on our new servers, that it was GDA 2020, or at least it was flagged as being GDA 94 as well, very clearly. The disadvantage, I guess, was that it meant that we had to account for every file that was on our old server and really carefully manage that migration. So we found that it worked for us, and this method of using new infrastructure might be viable for your organisation as well. And just a note about the scale of the project, I guess we found it was a complex project because we were transforming the data but also needing to upgrade software. So other organisations have made the decision perhaps to do the software upgrades first and then just handle the data as a different exercise or project. So certainly either of those approaches can work, and it may have benefits to sort of break it up like that. So finally, just the conclusions of that we reached for our project. We certainly found it was a challenging and complex project, but we're very happy to have to be now on this new datum of GDA2020. Certainly FME was a vital tool in allowing us to do the transformation ourselves and also really thoroughly keep track of the data and what we had done to it, so we had that really good audit trail. And certainly the things that we learned from the project about how FME could be used are techniques that we plan to reuse in our ongoing management of spatial data as well. And finally, I think it's important to note it's not just a technical project. There's a lot of technical aspects to it, of course, but it's also very important to consider the accompanying support as this is done. Support for the organisation's users, but also in supporting organisations that you might transfer data to and from. Finally, just like to acknowledge the great help that we had from all of those different areas. I won't go through them all, but a special mention to our GIS team, Chrissy Hind, Michael Hackins and Nikki Sakana for the power of work that they did throughout this project. And certainly we had a lot of external assistance we were very grateful for as well. So I thank you very much for your time today and listening to the presentation, and to One Spatial as well for the opportunity to present. My details are there if you have any further questions.
Very informative. We do have some questions that have come through. One of them was with regard to heighting. In the GIS transformation process, did you also transform heights RLs? If so, did you apply a new geoid for AHD values? Did you want to have an answer at that one?
Yeah, thanks, Andre. Yeah, in the main, our data was 2D. The references that were to AHD, we did consult about that, and we were informed it wasn't something that we needed to consider for that particular data set, but I'd probably have to get back with a little bit more detail if the questioner there had a bit more detail about what they were after there.
Okay, thank you. Another question we've got is, what budget did you need for the project?
Yeah, we had approximately between 30 and 35,000. So that was, we made up of our FME license that we purchased, the database version, also the upgrade assistance for Intramaps 9.8 and our Roam mobile data capture software as well. So of course each organisation be different in whether the project just involves the data transformation only, or are there software upgrades as well, and also what skills and resources are available in-house as well.
Okay, thank you. And we've got another one here. Were there any transformers or components of FME that were particularly important for this project?
Yes, a couple, I guess, come to mind that hadn't used before was the feature reader. So that allows you to read any FME supported format. So rather than putting that specific format in the workspace, you could use FME to read that file path or that database table name, and then dynamically get the attributes and the data types there and use those in the translation. So in conjunction with the dynamic writer. So that was what we used as well, so that we didn't have to put those specific feature types in the workspace, but use the dynamic writer. So that simplified the workspace a lot.
Okay, excellent. Another one. What was your approach for imagery?
So yes, with imagery, we took advice there, and I guess the common advice seemed to be to not convert imagery, but to allow your GIS software to reproject. We took a hybrid approach, I guess we could call it. We didn't transform all of our historic imagery tiles. So we took them across to our new infrastructure flagged as GDA94. But we decided that we'd be benefited in having mosaics of our different supplies in GDA 2020 so that we could easily give them out to contractors if need be. So we took that approach in just using FME to create those mosaics.
Thank you again, Jamie, and stick around. We will have you on the panel after this.
Thank you.
Okay, our next presenter is Ashish Manandhar, is a senior consultant with One Spatial, and I will ask Ashish to introduce himself, and he will be presenting on PAI, Positional Accuracy Improvement. Welcome, Ashish.
Thanks, Andre, and thanks, Jamie, for the informative case study on your migration from GDA94 to GDA2020. I'm Ashish Manandhar, and today I'm going to demonstrate how One Spatial's Positional Accuracy Improvement, or PAI in short, can be helpful to have accurate spatial data while you are in the process of migration to GDA2020. Let me start with what is PAI. While on a field survey, you might have encountered location inaccuracy. You might have noticed that the location of assets you are standing next to is sometimes displayed several meters away on your mobile device. Sometimes you may have datasets or multiple datasets which need to align with each other, but actually they do not. So these are common PAI issues. Fundamentally, positional accuracy improvement is moving location data from one coordinate to another, but One Spatial's PAI system is an automated system used to improve the positional accuracy of features of a map, and here we aim to improve the accuracy without compromising the shape or the topology of the feature. So there are three types of PAI processes. The first one being traditional positional improvement. You may have asset datasets like water network, electricity, or footpath, or any other asset network, which were captured with reference to a dataset such as land parcel dataset. When the reference dataset has been improved by the responsible authority, you will need to update the asset data, your asset data, to maintain the spatial relationship with the improved reference map. For example, when migrating from GDA94 to 2020, councils may want to migrate from council-maintained cadastre dataset to state-maintained cadastre dataset. So here we will need to ensure that all the assets that were based on the council maintained cadastre dataset will still maintain the topological relationships with the state-maintained cadastre data. Another use case here is when authorities perform base data improvement programs. For example, the Victoria's Digital Cadastre Modernization, or DCM program. It is a program to improve the spatial data of the land parcels. And hence, if your data is dependent on the land parcel, then you would need to realign your datasets to the new improved base data from the DCM project. Another type of PAI would be a generalized positional improvement. Sometimes you periodically recapture location data of some of your asset data. For example, this information coming from GPS or LiDAR or during asset maintenance or site survey. Since this process is capturing only a few asset data, we will need to perform PAI to calculate the incremental shift and then apply them to the entire data set or entire asset data so that it will match your new recaptured locations. For example, you may have collected new electricity pole data from GPS or LiDAR, and you will have new pole locations, but you still need to shift the cables and equipments that go along with it. Here, PAI solution will be useful to shift all asset data based on the old and new location of the poles. The third type of PAI process could be conflation. Conflation is merging new data into master dataset, and this may include updating the master dataset, such as handling updates, additions or deletions, or changing of attributes. For example, a new data set submitted by property developers or new asset data sourced from third parties, such as new trees data. So here we can use PAI to merge the new data with the existing data so that the relationships are maintained. So now I'd like to talk about shift vectors. Shift vectors are an important part or component in the PAI process. They are also called as link vectors, and they provide mapping from an identified point in the original reference to the same point in the improved reference. It is very important to ensure that they are fit for purpose. Some guidelines to identify useful shift vectors are that they should be similar in terms of magnitude and direction. They should not exhibit any random behavior, or we might call them outliers. They should not be associated with real world change. And here I mean that a shift vector should not link a corner of a building with a corner of a new extension of a building. So that would be a real world change. Shifts generated on points that are difficult to identify on the real world should also be avoided, such as shifts generated based on road center lines. Also, zero shifts are very important to lock in positions that are correct. So now I'd like to explain the stages of one integrate PAI process. The process is divided into 4 stages, and it can be customized as per the user requirements. The first stage is generating the shift vectors. Generating good quality shift vectors is very important, and one special PAI solution has pre-built algorithms to match the start and end points, and it will generate centroid and even vertex to vertex shifts. The matching process includes identifying junctions and identifying zero shifts, which are a higher priority for good quality shifts. The next stage is sanitizing the shift vectors. it is very important to ensure the shift vectors are fit for purpose. So if you have shift vectors sourced from another third party, we can use them in the PAI system to sanitize them so that the outliers and non-topographic shift vectors are identified, such as the road center lines. Also, outliers can be removed. Here, I like to highlight that identification of outliers is important as they help to find real-world data change, and this might be important or useful for any manual correction which might be required at the end of the process. Here we'll also classify shift vectors, including zero shifts and outliers. So we can get the shift vectors, your shift vectors from GDA94 to 2020 can also be used here. And with the third, and that will pass on to the third stage, which is transforming the data. So one spatial PAI solution will shift all required data based on the shift vectors, and it will do so using an intelligent triangulation approach. Here, it will constrain the shape and location of immutable geometries during shift, and it will try to preserve the shape and relationship between the features, and we can also optionally snap source or target data to the old or new reference. Finally, the fourth stage of PAI is to have proper validations and reporting. As reporting is very important, as we want to know where all of the shifts have occurred or have been successful. So here we can put in different kind of rules based on user requirements, such as analyzing geometry change or angle change. We can analyze connectivity and relationship to the reference data and report the significant differences. Also, we can generate outlier influence area geometries, and we can manually update if required. So moving on, here I have the use case where a council is switching to or migrating to land parcel layer maintained by council themselves to a land parcel layer maintained by the state while they are in the process of transforming from GDA94 to GDA2020. Here in the picture, we can see the council maintain land parcel layers in red and the council footpath in blue. And we can see that they both align with each other. But when the council wants to move to state cadastre, if we overlay the state cadastre green on top of the council cadastre, we can see that they do not align with each other. Both of them are in the same GDA 2020, but still they do not align with each other. And hence, there are some discrepancies. So if the council switches to state cadastre, we can see that the footpath and the state cadastre will overlap or have gaps, and hence the data will not align to each other. So here we will need a PAI process which will calculate the shift vectors between the two cadastre layers and apply them to the footpath or any other asset data that council would maintain. So I have an image here where I've generated the shift vectors, where the PAI system has generated the shift vectors based on the two council cadastres or land parcels. We can see the small shift vectors in each of the nodes or corner points, and the PAI will use the shift vectors to shift the footpath layer, and now we can see that the council footpath layer will align with the state cadastre layer. So this was one example where PAI can be very helpful for in your migration from GDA94 to GDA2020. So that was theory. Now I'd like to demonstrate the user interface for PAI. Okay, so the PAI uses one data gateway as the front end for the system. One data gateway is an easy to use web-based data submission portal. And it has got user authentication and dashboarding and project management bits as well. So there are 4 stages in a PAI system, as I mentioned earlier. The first stage being generate shift vectors. So this will calculate the difference between the two cadastre layers and generate the shift vectors from it. The second stage is accessing the shift vectors and evaluating them, and it'll make corrections or filtering the shift vectors as required. The third stage is using the shift vectors to move your required asset data. The first stage I have put in is optional and is like moving the cadastre data to the to the new cadastre, but that is optionally if we want to keep them. So these 4 steps are customizable, and we can put in our own rules to set them up. Also, some use cases may not require generating the shift vectors, so we can just start with step 2, or if we have sanitized shift vectors, then we can just start with step 3. So I'm going to demonstrate one of the step, and it is similar to all of the others. So I'm going to demonstrate step 3. So clicking on the icon, it shows me the list of previous runs of those shifts. I'm going to start a new submission. And here we have the data screen, the screen which allows you to upload data. One PAI can support multiple kinds of data sets, such as shapefile, geodatabase, or even database connections directly. So I'm going to supply with the asset data that I need to migrate or shift. So it's just a quick click, and you can even drag and drop your data to the required boxes. So I will drag and drop the evaluated shifts vectors that I've generated from stage 1 and stage 2. And finally, the target cadastre data that I want to that is used here for displaying purposes. So after the data has been uploaded, hit continue, and the data will be uploaded. And I'll And here we have the reconfigure mapping screen where if we want to, we can configure the mapping of the data to one spatial schema mappings, but as you saw, it will automatically map if it knows the mappings. So hit continue, and we can see that it will start processing. It has opened the data sources, reading the asset data and also the shift vectors, and has applied those shifts, calculated the shifts required for the footpaths and applied them to the whole asset data. So we can view these results on the map as well. It's got a nice map interface. I'm just going to start from the first and going to turn off some of the layers that we are not interested in. These are the layers which PI will use internally. So, okay, so this is the first open data, which is the opening the footpaths layer. And this is the state cadastre data. So we can see there is quite significant gaps and overlaps, even if they are in the same 2020 datum. So opening the shift vectors. So we have the shift vectors supplied, and this is the calculating the shift vectors for the footpaths. And in the next few steps, we can see that, yep, there it was. So it has moved the footpaths to match with the shift vectors to match the cadastre data. And here it is trying to preserve the shape and the relationship with the cadastre data as we have described in our rules. So so that was the process to run the PAI system, and we hit to resume, and it will submit the process, submit the data, and the submission right now is processing the submission. And if we hit continue, we can download the we get the report. We can download the asset data that has been transformed. We can view a PDF report which will show the number of features that have been processed and what actions has been applied and shifted accordingly. And finally, we'll close the submission, and we can start with a new submission if required. That is all for my presentation for PAI. Hope you enjoyed it, and if you have any questions, please let me know.
Thank you, Ashish. Okay, I've got a question here. How do you validate which data set is correct? PAI sounds like a term for correcting inaccurate data.
Yes, so we will have new data sets or new reference that we get from new GPS locations or LiDAR or data, and we can set up rules to understand so that the data will conform to those rules. Sometimes our LiDAR data may have identified a tree as a pole, so we can set up rules to check if the identified pole matches the rules required for the poles. So we can set up different rules as per the data set as required.
Okay, Thank you. Another question that's come through, does one spatial offer a service to perform PAI tasks for supplied data or just supply one data system to perform the tasks? Did you want to answer that?
Yes, yes, Andre. Yep, we can provide services for PAI. We can analyze your data, work with you to check the rules that might be required. We already have a set of rules which will be applicable to most PAI projects, and yeah, we'd be happy to help you in with the service.
Okay, I've got another question here. What data formats can be used in PAI?
Yeah, so PAI supports a wide variety of data sets. You can use like common formats such as shape, file geodatabase, map info, and even database connections like Postgres or Microsoft SQL Server. Yeah, so there are very different kinds of data sets supported.
Okay.
Data formats supported, sorry.
Thank you. Another question has come here. Can I use shift vectors to shift from GDA94 to GDA2020?
Yes, we can use the shift vectors to convert to shift your assets from 94 to 2020 if you have the shift vectors, and also we can set the projection to 2020 afterwards. Yep.
Okay, thank you. Look, in light of the fact that we are running a little bit over time, I'll stop it there and we will go to our panel now. We have a special guest, Richard Stanaway, Geodesy consultant at Quick Close, and we will have our four presenters or four people on the panel. Jamie McKinney, Ashish, Richard, and Michael Stoddard from One Spatial as well. So, okay, all righty. I thank you very much, gentlemen, for this afternoon. What I'll do is I'll shoot off with a question here that's come through. Data that is transformed, is its origins important when converting to GDA 2020? So I'll hand that over to you, Richard, if you want to have an answer to that one.
Yep, good afternoon, everybody. Yeah, the provenance of the data is really quite important. So knowing how the data was connected to the datum is really important. So, you know, was it surveyed by GPS from a coarse network? Was it surveyed from a passive, PSM, SSM benchmark type genetic mark, or was it from controlled imagery, or was it transformed from earlier AGD66 data, for instance? So there's different ways that data has a provenance. So if that data is used to be transformed to GDA 2020, you really need to know, well, how good was it in the old datum? And the PIA approach is actually quite good because you can potentially shift bad data or badly positioned data to a to GDA 2020 that way, but that's only really good if the data you're shifting it to is actually validated as GDA 2020. Otherwise, you're just transforming bad data using an accurate shift vector to bad data. So it's really, you want to try and avoid that situation. So the provenance of the data is really important, so that you can use the right transformation method. Definitely, yeah.
Does anyone else want to have any comment? No? Okay. Yep.
No, not really. Just that covered it.
Okay.
Extensively, I reckon.
Yeah. So I think using like knowing the data as the data source, as Richard mentioned, is also required to know which transformation to use in GDA94 to 2020, either just the conformal or conformal and distortion as well. So yeah, that's important.
Yeah, I could add to that. Yeah, like in Victoria, I think a lot of the distortions are quite small. But certainly in some jurisdictions like New South Wales, where there's really large distortions in GDA94, the conformal plus distortion is really a good way to, particularly for data that's been derived from a, like a ground-based geodetic network in a distorted area. It's actually really important to actually look at that really carefully, especially for New South Wales. Where the distortions have been quite large, that's really important.
Thank you. That kind of leads on to another question that's been asked here. As has been, there are two types of transformations to GDA that we understand: the conformal and the grid shift methods. What's the difference between them, and is one better than the other? And if so, where would that be the case?
Yeah, well, I suppose that was, I probably already answered that one partially. Yeah, well, there's the most common one's the 7-parameter transformation, which is a direct, GDA94 to GDA2020, and that's generally quite suitable for, GDA94 based on a cause-based solution, because that cause-based solution is probably the closest you'll get to GDA94 in its original essence. But yeah, as I said, in areas where the survey, the survey data, and the layers in the data are surveyed from ground control in an area where there's been a lot of distortions, then you do need to have that that distortion grid transformation. Is really important. That's probably that's probably really what I want to say, is that you have to be really careful, what the provenance of the data is before launching into a transformation and making sure the right one is used. Then that's the conformal transformations an NTV2 based one, and there's actually two variants. There's one which is conformal, which is basically just a grid representation of a 7-parameter model. Very similar. You can they'll be interpolated using some sort of interpolation process, and then there's the grid, which includes the distortion part. And they add them together, and that's interpolated in for that. So that's fine.
Okay. Following on, there was a question that was asked of Jamie with regard to heights. Data sets of heights. Now, with regard to transforming for heights, the geoidal model, geoid model that is published, the importance of making sure that you utilise the GDA2020 geoid model when doing a transformation. Did anyone have any comments on that? Making sure that you are using that one instead of the old 94 geoid model?
Yeah, well, I could probably add quickly. Yeah, I mean, it's really important to use the right geoid with the right GDA. So, for GDA94, you have to use AusGeoid 09, but for GDA2020, you have to use AusGeoid 2020. I know of a few cases where people are using the old AusGeoid with GDA2020, and that leads to sort of 10-centimetre heighting errors, potentially. So that's really important to make sure the right one's used. But in terms of transforming AHD data sets, well, AHD is derived, if it's derived from GDA94 using AusGeoid 09, there's probably no real need to transform that because the AHD derived from GDA2020 is going to be reasonably similar. I mean, not exactly the same, but they're generally very similar. But you've got to consider the new AVWS, which is a new vertical working surface, that Geoscience Australia are looking at developing and implementing. So there will be some height differences with that, and again, some care needs to be used with that. Yeah.
Okay, thank you. Any other comments from the other? No.
Not myself.
No. Okay. I do have another question here with regard to spatial data. Should people keep records of their data prior to the transformation? And if so, how would you recommend to keep that? So, Jamie, when you did it, were you keeping records of the existing data?
Yeah, so in that data audit process, the first pass of that, I guess, was using FME to compile various useful features about the data set, and including what coordinate reference system it found that it was using. So we have that in our data audit list, and then we've got also what we converted that to. So for us, yeah, that was an important thing to have that record of what it was previously and what we've done to it and what it ended up as. Richard, do you want to have anything that you wanted to add to that?
Yeah, I think there's a really a lot of importance. You can't overstate the importance for keeping records of how data's been transformed, because with datums will be updated in the future, and if you transform data and you transform it again and you transform it again, and every time you transform data, you're introducing sort of certain amounts of uncertainty or lack of surety. You want to be able to look at the original data and be able to sort of follow that traceability right through the chain. So if there's any doubts or there's any sort of questions about it, you can actually say, yes, this is the data set we had before we transformed it, and you can actually revisit that. It's really important. And then keeping the metadata, the metadata reports that come from LiDAR, from imagery, those sort of documents are really, really important and need to be sort of kept safeguarded. That's definitely very important.
Yeah, that's actually something, just talking around to people when doing GDA, is exactly that. Making sure that the metadata is because that's one thing that they say it's quite important, or maybe not as probably appreciated as it should be, is how complete that having that metadata and passing that on and making sure it makes it through the conversion. Yeah, definitely something that stood out, I noticed.
Yeah, absolutely. And I think the other acid test is, I'm speaking from a survey background, a positioning background, that ultimately you want to be able to validate the your GDA2020 data by survey. So we have excellent geodetic infrastructure in Australia. It's some of the best in the world. The cores networks are brilliant. You can get very high accuracy positions very easily with standard GNSS equipment. It's just a good thing to validate your data set, against a benchmark standard of a geodetic survey of those key infrastructure points. So it says, we know that's ironclad. That's really good. We know that fits to the survey, and then that's something you can sort of move the data to that standard is actually a really good thing.
Okay, thank you. Question that's come through: should a validation survey be performed on transformed data to ensure accuracy? If so, should it be done for all or just certain circumstances?
Well, I mean, I could get Jamie or somebody else to discuss that one. I probably said my point, but that'd be good to hear the other view.
I guess when it came to our particular data sets, we weren't, I guess, dealing with survey data as such in the main. There might have been things that GIS data sets that we produced ourselves, or yeah, we weren't going to do, I guess, survey testing on those ones, but certainly what we found important was make sure our conversions, or have a way of testing that against another standard. So that's where we use that GDA utility from ICSM to have reference coordinates that we use to make sure that we've done the conversions in the right way.
Yeah, I think like GDA94 to 2020 is an important milestone for many organizations as well. So I think it's a good idea that while we are doing this, we are checking if the data matches or matches the business requirements, or while we have this opportunity, sanitize the data to check if there are any overlaps. So you may have overlaps before converting to GDA, before converting into GDA2020, and you actually don't need those overlaps. So you might sanitize the data to get rid of the overlaps during this process as well. I think this the whole conversion process is an opportunity for data sanitization as well. So having rules to check if the data is conformant to your needs is after conversion is, I think, is important, so that you get you have accuracy or confidence in your data.
Yeah, I guess I've also kind of just in my experience is also just depending on what type of organization you're in, or the type of accuracy is as well. There's plenty of people that deal with 10-meter resolutions or big resolutions where probably transforming the data is a smart move, but in terms of spending the money to go survey it and validate it and that sort of stuff, is it really worth it if you're not really relying on the highest accuracy of data anyway? So yeah, definitely kind of applies in certain sentences. Or the other way where it's you need precision accuracy and there's a lot of responsibility or money involved in it needing it to be in an accurate spot. So kind of just evaluating how important it is as well.
Thank you, gentlemen. Thank you, Jamie, for your presentation. Ashish, for your presentation, very much appreciated. Richard, thank you again for coming along as a special guest for the panel, and we look forward to. And Michael, thank you for your contribution as well. We look forward to catching up with you at some stage for our next GDA for next year,